Welcome everyone! In this presentation I want to introduce our work Summarize Dates First, where we propose a paradigm shift in timeline summarization. It is published as full paper at SIGIR 2021 and it is a joint work between me, Montagnuolo Quatra, Luca Cagliero and Elena Baralis from Politecnico di Torino, and Alberto Messina and Maurizio Montagnuolo from the Italian broadcaster RAI Research Center for Technological Innovation. In this work we focus on timeline summarization, so I want to first introduce some relevant definitions. First of all, what is a timeline? Well, as you can see in the slide, a timeline is an ordered sequence of dates in chronological order. Each date is associated to a short text description that summarizes the main events that took place in this specific date. As an example here, we have a short timeline covering the first salient events of COVID-19 topic. For example, on January 10th, for the first time, the gene sequencing for the new virus has been shared among researchers. It is a relevant information that should be included in a timeline describing COVID-19. To create a timeline that summarizes the events in chronological order, we also need to select relevant textual information from a given corpus. Automatic text summarization addresses this task by applying several syntactic and semantic heuristics for shortening a given text. In our case, we apply multi-document summarization to select a given number of sentences from a pool of news articles. Combining both the concepts of timeline and summarization, we can define the timeline summarization task. Given a collection of articles related to a specific topic, the goal is to select dates that are relevant for the topic and select short descriptions that give an overview of events happened in the selected dates. The timeline summarization pipeline usually starts with the collection of topic-specific corpus. We report in the slide an example of corpus related to COVID-19. Then, each article in the data collection is analyzed to find date references inside text. Those temporal references define the interlinking between dates. In fact, we exploit both publication dates and identified references to link dates between them. The next step is to define a ranking for dates. In our case, we use a graph-based representation where each date is represented as a node in the graph. Combining publication dates and in-text temporal references, we create weighted edges to connect the dates in the graph. Once the graph is generated, we experiment with different node centrality algorithms to provide a ranking for dates. This approach gives us the opportunity to have a ranked list of dates that we can use to define the resulting timeline. As final step of standard timeline summarization pipeline, we have date summarization. In this case, the first step is to create date-specific corpus by combining all the sentences that are published in this date or refers to it. At this point, once corpus is created, it is possible to apply any standard text summarization algorithm to select a given number of sentences as date representation. In our work, we propose a modification of the original pipeline that I just described, and we perform early summarization by summarizing content before selecting relevant dates. We then exploit this knowledge to enrich information for date selection. We also provide an efficient way to perform timeline updates, for which we do not need to recompute date summaries each time. Finally, we also propose a new benchmark dataset covering the COVID-19 topic. Let's start with the first contribution. The main modification in the pipeline structure consists in anticipating the single date summarization step. In this case, once the in-text date references are collected, for each date corpus we first select its relevant content. There are two main advantages when proceeding in this way. First, early summarization removes redundant content. Second, we can use date summary as its representation. Having a clean text representation for each date allows us to exploit high-level date references. In this case, besides exploiting date references at day level, it means sentences referring to a specific day in the past or in the future, we also exploit month-level reference, for example, March 2020 in this slide. To do so, we exploit date summaries and compute Rouge-based similarities between the referencing sentence and each date in the cited month. In the example, we have some text published on May 18, 2020 that refers to March of the same year. Of course, we are not sure to which specific date it refers to, so we compute the similarity score between the referencing sentence and the summaries of all dates in March 2020. We use this score to weight the references from May 18 to all the dates in March. This allows us to weigh more the dates whose content is similar to the referencing text, and so it could be more relevant to the event discussed in the referencing sentence. The shift of the summarization module in the pipeline allows also efficient updates of the timeline. Indeed, the summarization step is the most computationally intensive, and shifting it at the beginning of the timeline allows us to update the timeline without recomputing the summaries for all selected dates. When a new set of articles come for a new daily update, our pipeline computes first the summary for the new day, and then for each day that has been referenced. This is much cheaper than recomputing the summaries for all dates selected in the timeline. So, by anticipating the summarization phase, our timeline is more efficient with respect to previous approaches for daily updates. Last but not least, as contribution of our work, we also propose a new timeline dataset covering the topic of COVID-19. We call it COVID-TLS dataset. It includes more than 26,000 articles. The key dates in the selected dataset are 266, and it contains a large number of high-level references that are more than 60% of the total number of references. The data collection is available for research purposes on GitHub. Coming into the results of the proposed timeline summarization approach, we evaluated over 3 existing benchmark datasets plus the newly proposed one. The approach we propose is completely unsupervised, and we compare with a previous unsupervised approach that was based on submodular optimization and a recent supervised approach that exploits trained machine learning models to select salient dates. Here we report the result of specialized Rouge-based scores that are designed to evaluate timelines. Standard Rouge is also reported in the table as concat, but we mainly use agreement and alignment many-to-one scores that take into consideration also the date selection accuracy. We can see from the table that for Timeline 17 and Crisis, our method performs better than previous unsupervised ones, and in some cases it performs on par or better than supervised approaches. We observe a slight decrease in performance for entities that contains timelines about famous people's lives or corporational histories. On the other hand, the performance on the newly proposed COVID-TLS are superior to supervised and unsupervised methods. It should be noted here that the supervised model is trained on the other data collections because COVID-TLS consists of a single timeline, so there is no possibility to perform a train test split. Concerning date selection, we tested several graph ranking approaches, such as ITS or PageRank. But we also provide ranking by using the degree or the in degree of each node. In this case, the best performance are achieved by using the in-degree ranking, and our method performs better than all the others supervised and unsupervised, with an exception for the entities dataset. In this case, the training of the supervised approach benefits from the large number of training timelines that are available in this specific data collection. Finally, we also test the performance improvement on the date selection when using high-level references. In this case, we can notice that for timelines that are extracted from long-spanning events, for example entities or COVID TLS, we see a clear benefit. While for timeline 17, that includes shorter timelines, we see a slight decrease in the date selection F1 score. To conclude, we have seen a new approach for timeline summarization. The proposed method exploits single date summaries to enrich the information available for key date selection. The most effective selection method is based on a graph ranking approach, specifically on the ranking given by the in-degree of each node. Finally, in our evaluation, we found that unsupervised models show good performance when generating timelines of different and unprecedented events, such as the timeline of COVID-19. As future works, we plan to test multimodal learning to select not only text content, but also images or videos for salient dates. At the same time, we want to explore the usability of abstractive summarization algorithms when creating date summaries. In this case, we drop the constraint of selecting already existing sentences, and the output timeline could be more similar to the human-generated one. I thank you all for your attention, and I look forward to discuss with you about this paper at SIGIR 2021. Thank you.